as Academy, and today we are going to be discussing about colligative property, where we have what we call osmotic pressure. Now, before we can discuss about osmotic pressure, it's all about. So, what is osmosis? As a student, you need to know that osmosis can be defined as the process of the movement of what we call solvent molecules. So the movement can be diffusion of the solvent molecules from the region of higher concentration to the region of lower concentration and through a semi-permeable membrane. Okay, so that is the definition of osmosis there. Now let's talk about the osmotic pressure. So osmotic pressure is the pressure that must be applied to counteract what we call osmosis. That is what osmotic pressure is all about there. The pressure that must be applied to counteract or prevent osmosis is what refers to as osmotic pressure. Now, it should be noted that osmotic pressure is given by this symbol here. This is the symbol, like this. This is pi symbol. That is the symbol for osmotic pressure. So in that case, osmotic pressure, which is pi, is proportional to what we call the concentration and what we call the absolute temperature. Okay, so if you introduce constant, what are you going to have? We are going to have osmotic pressure equals to K followed by CT. Okay, now, but it should be noted that K equals to what we call R. The R, which is called the gas constant. Then in that place, we are going to rewrite this as pi, which is osmotic pressure, equals to the CRT. Now, if you check some materials, the concentration here can be written in form of M. So, if M equals to C, then we can rewrite this as pi equals to MRT. As simple as that. So the C or the M represent what we call the concentration in mole per dm cube, while the T represents what we call the absolute temperature. Okay. Now, from what we have here, you are given a particular problem in this place to solve. And the question here says you should calculate the osmotic pressure where the concentration, if the concentration is C, is given to be 1.0, okay, and you solve. And the question here says you should calculate the osmotic pressure where the concentration, if the concentration is C, is given to be 1.0, okay, and you're given that the temperature which is 300 Kelvin. Now, you are given the value of R in this place. The value of R here is 0.082. Now, this value of R in this place has the following units. Well, we have what we call atmosphere, dm cube, followed by per Kelvin, followed by per mole. That is the value of this one here, the unit of this. So, because of that, the unit of osmotic pressure in this place can be given in form of what we call atmosphere. Since you are dealing with what we call osmotic pressure, so pressure there, the unit of pressure is what we are going to use. But in another place, where the value of R is going to be 8.314. In this place, then we are using what we call the Newton per meter square. So the unit of osmotic pressure there will be what? Will be Newton per meter square. That is what we are going to use for it. Now, from what you have in this place, if we take this as the value of R, we are going to have pi equals to, by the formula that we have there, C followed by R followed by T, which is equal to 1 multiplied by 0.082 multiplied by 300. Now, if you make use of this, at the end of the day, what are you going to have there? That will give you 24.6 atmosphere. Take note of that, atmosphere. That will be the value for it. But if the question asks you to solve where the value of R in the question is this one that you have here, that means pi equals to, we are going to have 1 times 8.314 times 300. So what are we going to have here? That will give you 2494.2. So this one will be in Newton per meter squared. So that is how to solve the problem. Thank you very much.